idiosyncrasy management and how it is related to data science.
Oh, that's very interesting. Good question, Sumanto. Now, in fact, what happens is, for example, this is a matter of behavioral science. Okay, I mean, some people, they have got certain idiosyncrasies. Now, this kind of behavioral science, if the behavioral data can be placed, can be, I mean, for example, the behavioral data can be psychological data, which can be psychometrically, which can be monitored. That can be image data. That is, I mean, certain behavior which can be depicted through his behavior. And then it will be all unstructured, lots of data. And now these data set, they can be analyzed using big data, because for every person, there will be huge amount of data. And this data analytics will finally identify his major, idiosyncrasies, I mean, behavioral pattern, problem, whatever you call it. So yes, in fact, that's why that is one of the things, that there is no area which is not touched by data science. Absolutely no area. And those areas which have still not been touched, they will be touched now by data science, because the whole world is moving towards that. Then?
So yeah, the same person, Sumanto, he is also asking that what is weak ties in data analysis? Weak ties. WEAKTIES. Weak.
Weak
ties. Ties, kind of, he is asking TIES, ties. Weak ties in data analysis.
Weak ties in data analysis. Okay, so yes. Data analysis will, let us just see. Sumanto, can you slightly elaborate?
Okay, let me see.
Is there any provision by which they can?
Yeah, I can allow him to talk. Yes. Mr. Sumanto, you can talk now.
Sumanto, you are, hello?
Yes, sir. Can you hear me, sir?
Yeah. So
sir, you have to show your you have to show your slide, sir. In that slide, you have talked about some comparison between weak ties and hard ties, something like that. In your I think 10th slide, sir. So that slide, it's not clear to me.
Weak. Anyway,
maybe the term I am using, maybe some wrong is there, but
okay, maybe that you are having my number, so you can call me.
Thank you, sir.
Okay.
Thank you very much.
You can call me. We just have a look. I don't remember that whether I have written something like weak ties and strong ties. There may be, I mean, that's a general. Yeah, next.
Next question, sir. Soptik Ghosh, he is asking, is there any application of polymer and material science in drug industries? And what are the prospects of polymer?
Polymer and material science in drug industry?
Yes.
Yeah, that I think, Professor Shaha, you can elaborate a little bit.
Yeah. So, Soptik, if you can hear me, the polymer, as sir has already told, that today is the kind of era of polymer. So starting from raw material of any kind of drug to the biomedical device, like everything we need polymers, and these polymers could be synthetic polymer or even natural polymer. So yeah, and polymer and material science, this interface of these two vast topic is the matter of concern or matter of interest for the most of the people, interdisciplinary people, for chemistry, from physics, from biology. So these are the areas where
No,
drug,
what is, I think that Shoptik, he wants to know
yes,
that whether the polymers can directly be used for production of the drugs. That may
yes,
not be, but then
but
indirectly there will be a lot of
yes,
applications of polymers in the drug industry, in the
yes,
pharmaceuticals.
some organic polymers are there. They can use as raw material, and also some like it is all about materials. So yeah, you are right, sir. Indirectly and sometimes directly, that polymers can be used as the component of drug.
As the ingredient of a drug.
Yes, yes.
Hmm, hmm.
And regarding the prospect, it is like I would say huge prospect. Like from fabrication of drugs, today you can see the drugs are being delivered in through a vehicle. This vehicle is made of polymer. So people are working on the scaffold and this kind of patches and this kind of micro swimmers or micro carriers. This can be fabricated by 3D printing, and they can be delivered in a controlled and targeted manner. So yeah, for as a polymer scientist, you have the huge prospect in drug industry also for the fabrication of
So
this.
biopolymer is a very important area now today.
Yeah, from starting from cellulose to other polymers.
Hmm.
These are very interesting.
Okay, then what is the next question?
The next question is from Soumen Das. Has written that actually considering my long industry experience in power sector and satellite communication project, I need to do some research work on hardware simulation for achieving an optimum data through image processing on power devices and electrical network components. My question is, during research work, uh, I have to give more emphasis on hardware part or coding or accordingly necessary papers to be chosen for coursework.
Yeah, so appropriate papers will be suggested, and then he has to take those subjects as the coursework.
Actually, maybe I think he is doing PhD. That's why he is asking.
Right, in PhD, some coursework will be needed. The appropriate subjects will be suggested. In fact, Professor Mojumdar, I have already talked to him. So then he will have to do some few courseworks, and because hardware now, for him, doing any hardware will be a problem. It has to be all simulation kind
Right.
of things. Yeah.
So I think, sir,
Anything else?
no, no, we have addressed all the questions and queries. So now we can move to our next part, your lecture on the data science, covering all the aspects of data science and its application. So yes,
Okay.
now yeah, you can share.
Yeah, so this is, data science and its applications. What is the application now and what's going to be the application tomorrow? So naturally, since this is, let's first have a glimpses of data. In fact, this one I had already given a talk somewhere. So I'm using the same kind of slides. So as you can see that the data is, the quantum of data throughout the world is increasing. And it's very interesting that at the beginning of 2020, digital universe means the whole world today is digital. So it is estimated that we had about 44 zettabytes, and 1 zettabyte is 10 to the power 21 bytes, unthinkable. So that's a huge, huge amount. Now, this data that we have been talking about, these were generated by different social media sites. So every moment, all of you are using the social media sites. Financial houses, they are using data. Medical healthcare systems, they are using data. Shopping platforms, because shopping has become a very important area, they are using data. Automakers and others. But then this is, in my opinion, not the full range. Because in research now today, lots and lots of, for example, in pharmaceuticals, in drug industries, in materials, new material identification, in the genetical, in genetics, in bioinformatics. So lots of extraneous other kinds of data also are available, which possibly has not been mentioned here. At the beginning of 2020, the number of bytes in the digital universe, so that was several times more than the number of stars. So anyway, these are all standard things. And it will be almost, every hour it will be 463 exabytes. To be more precise, it will be a huge, huge amount of data. We'll be flooded with data. Now, the major point is, these are all some data which I could get again from the net. And so every 24 hours, 500 million tweets are tweeted on Twitter. So huge. I mean, in a sense that as on today, it's huge. Now the point is that will it increase this rate of data generation? The question is, the answer is yes. So why it will increase? Now even today, we have got 4G of this mobile communication. Once we switch over to 5G, then that itself will elevate the data transmission speed by almost 100 times. And so this will be one of the major things. So as you can see that since the data transmission speed is increasing, so the data generation also will increase accordingly. So in future, in India, I think that maybe that by next year it will be, or maybe by 2021, 22, there will be huge 5G cellular connections. Now, since in 1 or 2 years, we'll be again having considerable amount of 5G presence. So it will be expected that throughout the world, we can truly having an accelerated phase of data generation. Second important point is in 5G, in fact, in South Korea, they are one of the major customers of 5G. So even in June 2019, as you can see that they used 24 GB a month, which is again a huge amount of data. Such data usage is more than twice what typical 4G subscribers consume. So here itself, it will be much more. Similarly, a lot of smart speakers are coming. Now,
sir, just an interruption. Can you make this full slide of your presentation? It is not in full screen. It will be easier for us also. Yeah, now it's okay, sir. Okay, sir, continue, sir.
One is this 5G. The second important, point, factor, why the data because there will be huge number of IoT devices. So there are currently, there is an estimate that there are about 26 billion IoT devices which are already connected with the internet. So can you imagine that the whole global, our country's population, total number of people in India is 1.3 billion. The total number of people in the entire globe will be around, say, 7 to 8 billions. So there are 26, that is 3 times more of IoT devices which will be there throughout the globe. And that is in 2025.
Hello, Dr. Boshak,
Yes,
are you?
Dr.
Yes,
Shah.
yes, sir. I think he got disconnected somehow.
Okay.
Can you? Yeah, he's coming
Yeah.
back.
Yeah, in fact, there was a momentary.
Yes,
Net is so much
yes, it is unstable.
unreliable.
Connection is very unstable. Sir.
Yeah, it's very unreliable.
Yes, sir. You can continue.
Now, okay, so here is, can you hear me now?
We
Hello?
can hear you, but your presentation is not there. You have to share it.
I have shared it. Why the presentation is not there?
One more, sir. You have to give the video mode.
Hello, can you hear me or you?
Yes, yes, we can hear. We can hear you.
Presentation.
You can go to the share. Sir, share screen গিয়ে you can.
শেয়ার তো করছি তো, শেয়ার
Oh.
করলাম তখন।
Dr. Boshak, can you see presentation কি দেখা যাচ্ছে?
I cannot see, sir, the presentation.
আমি আবার একটু ইয়ে করছি।
হ্যাঁ, একটু বেরিয়ে আরেকবার লিভ করে জয়েন করতে পারেন।
Yeah, I think that now it will come. Is it okay?
Sir, actually, yeah, we can see you, we can hear you, but the presentation slide we cannot see.
Just a minute. Yeah, you tell everybody just to wait for.
Yes, yes. All so attendees just pardon us that it is due to some technical issues and internet connection, unstable internet connection. We are working on it. Yes.
এখন কি দেখা যাচ্ছে?
আপনাকে দেখা যাচ্ছে স্যার, ভিডিও দেখা যাচ্ছে, আপনাকে দেখা যাচ্ছে। এবার আপনাকে ওই শেয়ার স্ক্রিনটা শেয়ার করুন।
এই তো জয়েন এ মিটিং, তো আবার নতুন করে কি জয়েন করব? মুশকিল। হ্যাঁ, এটা তো কোথায় এটা মিনিমাইজ মোড, হ্যাঁ, শেয়ার স্ক্রিন।
Yes, yes, it's now it's
Now
coming.
you can see, no?
Yes, yes. Full screen, sir. Just can you make it full screen?
হ্যাঁ,
So, yeah.
So sorry for the
Yes.
problem. Now, So the first thing is then a huge amount of, now tomorrow, for example, the electrical engineers, now tomorrow's electrical meters will all be smart meters. In fact, all the not only electrical meters, but then in already many of the Western countries, water meter, gas consumption, everything, they are now putting it to the cloud. So what is happening is they are all generating huge amount of data. For example, my own electricity, now it may give electricity, my consumption may be highest when there is a peak load. So the big data analytics, it will not only give me the complete details about almost every hour, how much electricity I have consumed or how much water I have consumed, but then more importantly, it will also prescriptive kind of analytics it will give. That means it will prescribe that you do not use so much of electricity at this hour or you use in that hour. So these are all, some of the things which are generating, not only generating data, but the analysis of data also is becoming very high. It's not only in social media, but as I said, that almost in everywhere. It's a considerable amount of geospatial data. For example, for cell phones, now you need to locate localization of any person, any vehicle, you need, the GPS data. Now this GPS data, this again gives you every moment huge amount of data on all over the globe. So GPS data, the remote sensing data, the satellite data, everything is increasing like anything. So let's see that we have then come to a stage where we have to use big data. Now big data means it is nothing but we will have the data which in the earlier days or even today is being analyzed in a certain way. The nature of the data yesterday was simple. As we call it, say the financial data, whether it is even the social media data, they were, as we call it, it was structured data. So not much of complexity in the data. Today's data, it is becoming unstructured or semi-structured data. Unstructured means in a data, there may be some, some word file, there may be images, there may be videos, there may be graphics. So the data now contains multiple and of different types of data. So this makes it an unstructured data. There is no specific structure of the data that you are getting today for analysis. For example, a person's healthcare. In my healthcare, I will be having my own past, whatever diseases you had. So that is one kind of prescription. Then what kind of medicines you have taken, that is another kind of data. Then your current problem, your ECG, your X-ray, if it is there, CT scan, MRI, or any other modalities of data. So those are all image data. And more importantly today, many people, they are trying to find out the socio-economic data of the patient. Because even in COVID days, you can see that a lot of people, they are not getting any bed. And so tomorrow's things, it will be analyzing this data, which is of huge amount, but the data nature will be unstructured. So big data means the data volume is increasing like anything. It is getting generated with a huge velocity. So this is the second V, as it is called. One is the volume is huge, one is the velocity at which it is generated. Tremendous rate it is getting generated. And then comes the variety of data. So data is of different varieties. So image, video, graphics, general, numeric data, or text data, emails, and also everything together, it is huge. Multi-dimensional data with variety and the veracity, that is what is the truthfulness of the data, because most of the data today, much of it is fake data, as we all know now. Same fake things are being circulated all over the globe. So a huge amount of fake data is there. Now, how do you get rid of that fake data from the real data? So this is known as data cleaning. So the veracity is very important. You have to, before sending anything, you have to be very clear about it. So together with everything, all these 4 or 5 entities or the characteristics, we call this data set as a big data set. So naturally, the complexity involved in analyzing this big data is definitely, it requires a different type of computing environment. Because in the earlier days, we had one type of computing environment. Now we need a different type of computing environment altogether. So there are limitations of the existing solutions, and majority of the limitations is that existing solutions typically, mostly, I'm not saying that fully, relies on structured data, whereas now the data size is big, the data structures are all, they are unstructured. So solving the problem, the first point that comes is, how will you store this data? So data storage now becomes a big problem. Storage means not in terms of you purchase some data storage units, hardware, but more importantly, you have to store the data in such a way that the computations can be done very fast. So this is important. So one is the storage of data. And now, you cannot have a centralized data storage as we used to have earlier. Not even one server and 2, 3, 4 few clients. No, not like that. So you have to have a decentralized storage media. And then we have to find out that how the computations can be done. So this whole thing, it's known as an ecosystem of Hadoop is the language. It's a big data framework which people all over the globe now they are using to tackle the big data. Because in data science, we have to, make use of this big data, whether it is in healthcare or in business houses, everywhere. We need in environmental scenarios. And we have to understand the ecosystem in which they can be. So Apache Hadoop and Apache Spark. So there will be a specific few lectures on that. 2 of our professors, they will be not only giving lectures, but then they will also be taking some, they will be taking the hands-on so that everybody learns how to write the codes in Hadoop and all. Only in few lectures it cannot be done, but in our courses, these will be taught in a big way. So Hadoop, its core components and a very new kind of architecture. So this is very interesting. It is known as Hadoop data file system architecture. So I am now coming to that. Now, one of the things in big data framework is the storage capacity. Now it is growing exponentially, but the data processing speed, it has not kept up. So this is interesting. For example, in 1990, one statistics shows that to store 1400 megabytes of data, 1990 means 30 years back. So to store 1400 megabytes, in fact, 30 years means it's a huge time in computer science. In fact, the current CEO of Google, this Sundar Pichai, he was in his first year. So just to store, and I remember that in IITs then the kind of facilities that we had and the kind of facilities that are there now, it's sea change. So transfer speed of 4.5 Mbps, if we consider, then an entire drive it used to take 5 minutes for reading it. Same thing in 2010, if the storage is 1 terabyte, 1 terabyte is huge, but transfer speed, so the storage has increased quite a lot from 1400 MB to 1 TB. Transfer speed, it has also increased, but only 100 Mbps. So read the entire drive in 3 hours. So from 5 minutes, now, exponentially the data size is increasing, no doubt about it. But then even reading it itself is taking much more time. Today, using Hadoop, an important thing is that we have to speed up the data, not only transfer speed and the data analysis. So 100 drives, if it is decentralized, they are working at the same time. And today, the same 1 TB, to read it, it takes only 2 minutes. So from 2010 to 2020, in 10 years time, from 3 years, it reduces to 2 minutes only. So 3 hours to 2 minutes. So here is the overall scenario. For example, this is an image of New York Stock Exchange, which generates about 1 terabyte of data, of new data every day. Imagine that this is only one stock exchange. Throughout the globe, in all the cities, there are some stock exchanges. So imagine the amount of data which will be generated only in the stock exchanges. And the nature of that data is, as I have shown you here, up to 1990, it used to be simply, rational, it used to be mainly the structure. But then gradually, if you can just see, I do not have application data, which is shown in pink, they have become much more complex. And then the stored digital information, it has gone up to exabytes, 10 to the power 18. So it has grown by 62%, but more importantly, it will be growing to 1.2 zettabytes this year, in 1 year. So this is, of course, a little bit old statistics. That is about 2000, 7, 8 or 2000, 15, 16, around that time. So this is a kind of situation. So Hadoop, just a small history. In fact, the genesis of Hadoop, which is the framework for big data analysis. So it is, genesis is in 2004, Google, they published 2 very important work. One is Google File System, and the other one is MapReduce Framework. Now these 2 very important papers were useful, and because one dog cutting and his team, that is known as Nudge team, they took that Google's frameworks and then they indexed the web, and then they just simply, in the same line as the Google file system was developed, they developed a similar kind of a file system. So Yahoo in 2006, in 2 years' time, they hired dog cutting, because this cutting is the person, Douglas is the person who has actually developed this Hadoop file system to work on Hadoop with a dedicated team. So Hadoop became Apache's top level project in 2018. Now this dog cutting, his son, he had a small elephant, toy elephant, and the name of that toy elephant was Hadoop, and he had given the name of the entire, project as Hadoop project. So anyway, job-wise, if you can see that job-wise, it is constantly from 2012, 13, 14, 15, it's increasing and increasing. Hadoop job, if you know it, then your increase of job will be huge, because there are so many companies which are truly very big users of Hadoop. Amazon.com, eBay, AOL, Facebook, Yahoo, Twitter, Adobe, everybody, IBM, everybody is using. They're big. So Hadoop cluster, will not go much into detail about the whole thing, but as you can see that so there are several clients, and the total amount of data is now distributed amongst the data nodes. One of the important characteristics of Hadoop is that Hadoop uses cheap commodity server hardware. Because earlier days, our servers were very costly. We are using very costly servers. Today, the whole philosophy is that in Hadoop, that don't use a very costly server. You take the commodity server hardware. It will be cheap and they will be much more, simple. But then what you need is you distribute the data. As you can see that here we have distributed the data node 1, 2, 3, etc. It goes on up to maybe data node 100. So these data nodes, they are for storage of data of certain amount. For example, you may say that okay, each of these data nodes can store about say 250 MB, whatever it may be. So there are some switches through which the clients are connected to these data nodes. So this is another very important Hadoop principle is that usually what happens, you have done the processor, the design of a processor is such that the data is sent to the processor code and the processing is done. Okay, but then here in case of Hadoop, the code is transferred to the data rather than the data being transferred to the code. So this is very, very interesting kind of a concept. So don't send data to the code, but then send the code to each of these data modules so that you can do the processing in each of these data modules. So I am not going into the much of details, but then this Hadoop data file system and MapReduce, which is basically one of the major cluster management techniques, along with the corresponding data processing also is by YARN, which is also cluster and remote resource management unit. So these two together, they get the entire Hadoop environment. So large file storage, as I said, maybe terabytes, petabytes, now zettabytes, huge amount of use the commodity hardware. So the architecture is, I will not go into much detail. So as you can see that there are several racks. In each rack, there are data nodes, there are clients, and then there is another thing which is known as name node. So the data is stored in the different data nodes, and name node will have the metadata. Metadata means the complete information about the data which you have stored in each of the data nodes. So it is interesting that these data nodes and these name nodes, they together with the Hadoop's MapReduce, they give us a huge amount of very good ecosystem by which you can do the complete analysis. So let's see an important information, that is before analyzing the big data, the smart meters, which is a very important thing because today's meters will all be smart meters. So as you can see that consumers' bill were increasing, energy utilization bill. But if you just analyze the big data, then by prescriptive logic, the CESC can tell us that, okay, this is your daily electric usage. You are not getting any information. CESC only gives you, this is your bill, and you have to pay that bill. Now, but then this is not the whole thing. You have to analyze it, and I want to know that every day why my bill is so high. During peak load, we need the users sometimes requires more energy. So how I can reduce my my electricity bill by using the off-peak times, so etc., etc. So this is only possible an optimization of energy utilization if you can consider the big data. Another very important thing is the data mining, as I said. So in data analysis, in data science, you need the data warehousing. How do you store the data? You need the data security. How do you ensure that the data is secured? Your data does not have anything, which, because data security today, say financial data, is very, very important. So it should be appropriately encrypted data. Different types of techniques are there for encryption of data. Similarly, the data mining is very important because you have to get rid of some of the data which are not that important. So you need data mining, and then finally you have to do the data analysis. So together with everything, you need a data, a big data environment. So storage of big data, how they will be stored, that is also very important because HDFS and S3, they are scalable. S3 is another one that has been developed by Amazon. They call it a simple storage service. So HDFS and S3, they are scalable, but then Amazon uses their cloud, whereas HDFS do not use the cloud. So MapReduce is how it is reduced and counting. I will not take much time. Let's go to the IoT and cloud computing. This is another very important subject of data science. So IoT means, as I said earlier, that industrial systems, they use sensors to monitor both the industrial parameters. For example, in the today's world, in the smart building, smart city project is a very pet project of the government of India. So there, all the water, electricity, the agriculture, everything in the smart cities, and I have written stroke smart villages. Everything should be monitored continuously. So how much amount of water requirement, how much amount of water is being used in the city, how much amount of water is there, how much amount of water is getting drained, everything. In the cities, you need pedestrian traffic, vehicular traffic, how much of it is there. Every building gives you the data, that is the data from the smart buildings. In the village side, you get the data, information about water, electricity, agriculture is very important. So all these smart cities, smart villages, smart buildings, they use the different type of sensors to sense the data, and this is known as Internet of Things, and they are all connected to the internet. How they are connected to the internet? And in the internet, in many cases, the data can be stored in the cloud. So that becomes another thing which is known as cloud computing. How do you store the data in the cloud? Nowadays, whether it's Google or Amazon or, everybody has got their cloud systems, and there is a huge competition. Google is giving to the students some amount of cloud free of cost so that the students can make use of that cloud computing on their own. Even to academic institutions also, they are giving it at a much cheaper rate. So Amazon, which has got one of the strongest presence in the cloud, they also have got something more to deliver. Similarly, Microsoft's cloud. So everybody is ready with the cloud because tomorrow's world, most of the things, the cloud, the advantage is that you as an user, you need not do anything. All that you need is to store your data to the cloud. You don't need any server. Who will do that? The cloud. Server management, cloud will do. The computation, cloud will do. It's all the data security, it is cloud's responsibility. So you have purchased Amazon cloud, so it is the responsibility of Amazon to ensure that all your data is secured. So this is again another very important thing which is coming in a big way. So Internet of Things, that is the sensor. IoTs are mostly sensors. They are all networked sensors. That means each sensor is connected with other sensor, and they are all connected with the cloud. medical system, we need a large number of patient monitoring system. We need not do everything in the cloud, because as I have shown you just now, Hadoop, it does not make use of cloud. You can have your own very simple, this commodity server systems where you can store this data. You don't need cloud all the time. Cloud may be initially a little bit costly, but in cloud you don't have any botheration. That is a good thing. But in medical systems today, if we could have the IoT and cloud computing, then during the COVID pandemonium, this pandemic, we could have tackled the situation in a much, much better way, whether it is at home or in hospital or in emergency vehicle, everywhere. I mean, people are just moving from one hospital to another, not getting a bed. Everything, imagine that if all the data is available and continuously being processed by the computer, only thing is the politician should ensure that they will not do anything. Everything will be determined by your computer program, your analytics. So sensor network is one way. It's very important. That is the set of sensors which are networked, and then they are doing the things. Alert system, which is so important. For example, in somewhere, some accident has happened, immediately it should be alerted. Somewhere there is a fire accident, so it should be alerted through sensors. So data is getting gathered from and analyzed continuously from everywhere, from road to bed to your kitchen to your healthcare to agriculture, everywhere. So you have to make use of all these things. So reliability and availability is very important, and the service lifetime, it should be giving a complete lifetime for a long number of years. IoT should work. So this is one small architecture. Suppose there are plants, so many plants, and there are from every device there is a device hub. Data is coming to the hub. And then it is coming to fog. So fog is what? Fog processor, it can compute not huge amount of data, but then from the data hub, the data is stored into the fog processor, which can compute moderate amount of data. Huge amount of data is stored in the cloud. So this is in the cloud. So I am not going into the IoT oriented protocols. I mean, all these things will be taught in our course, but then the IoT devices is very important, because we must ensure that these devices, the sensors that you are using, they do not consume much power. So their duty cycle should be reasonably well. Suppose if the sensor is used for a longer duration and then it becomes idle for some time, again it works, because you should not give power all the time to the device which is not being used. Even in your PC, in your laptop, in your mobile phone, if you are not using it, becomes sort of dark. So you do not make use of power unnecessarily, because power is everything and energy is everything today. So lower duty cycle means that you do the lower energy consumption. So it has to be optimized, that how much energy I should consume in the sensor so that it will be optimized. As you can see that there are local sensor network. Some are, one type of sensor, some pressure sensor, temperature sensor, this mechanical sensors, strain sensors. So there may be sensors like these. There may be sensors like, different types of biochemical sensors. Whatever it may be, the sensors are all connected together through a local sensor network. Then from the sensor network, it goes to gateway devices. Through the gateway, from gateway to the cloud, there is internet connectivity. So this is very interesting, that how internet gets this kind of devices. So Internet of Things, this tag, it can be used in transportation, factories, water, energy, healthcare, agriculture, governance, finance. You talk about anything, you can have the Internet of Things. And these are coming. The point is in data science, this will be one of the major things which are coming in a big way, because tomorrow the problems of the whole globe is increasing like anything. Otherwise, it will be like, our COVID situation in Calcutta. Nobody cares anything, and nobody cares for energy consumption, water consumption, transportation. I mean, the roads are absolutely without traffic. It's all uncertain. So we need to have from gateway through internet, it should be going to the cloud, and there it will be analyzed. So IoT, again, as I said, that there are some specific platforms and IoT application platform and gateway platform. From the sensors to the gateway, it goes to the IoT application platform. And then you can do some applications in your mobile also. So not necessarily everything will be in your cloud. So there are different type of hardware devices, software devices, the communication platform, cloud platform, etc. These all will be taught there. Suppose I have just shown you only a simple example in agriculture. So in agriculture, what you need is you need to map the soil, you need to map the crops, you need to have the weather prediction. Everything needs the sensors. So fertilizer, how much amount of fertilizer will be recommended? Who will do that analytics? Disease detection, as I was mentioning earlier, pest management, automated irrigation system, everything should be useful in agriculture. So basically, I mean, for soil and crop monitoring, even in a small country like Ireland, they use the satellite-based data. In our country, we still don't use it. Nobody knows what is the kind of soil here. The soil mapping has to be done. Accordingly, there should be advisory to the farmer that you have this kind of crops. Weather forecast, which is so important. Now we are having weather forecast, like say rainfall, sometimes snowfall, sometimes storm. Storm we are having very good, I mean, even a week ahead we can come to know whether there's a huge storm. Wind speed we can have. So there are some predictive kind of analysis which will be very important in weather forecasting. That is what's going to happen tomorrow. So recommendation of fertilizer. The farmers, they do not know that how much amount of fertilizer or what type of fertilizer is used or should be used in case the type of soil is this. So all that you need is chemical sensor, physical, biological properties of soil. And then automatically you can make a complete soil map of the entire global, the village, the rural areas. And then the IoT, analyzer, the data analytics will say that this kind of fertilizer will be useful for your crop. Similarly, disease detection, pest management, everybody uses huge amount of pesticides. And that really has an adverse effect on the health. All that we are purchasing from the market, they are full of pesticides. Now, this is a major problem. Now, how much amount of pesticide has to be used? The optimized part of it, that has to be analytics. So data science comes in a big way in all these different areas. So automatic irrigation system, how much amount of water you will give, because water is a big problem now, because water, its usefulness and its utility has to be optimized. Big data in healthcare, so it will mean radiological imaging, in histopathological and cytological images, in gene sequencing, in disease diagnostics, everywhere, the huge amount in hospital management system, a hospital, every moment it creates a huge amount of data. So these are all about the data. Finally, I will just talk about the deep neural network or the neural network. How many people are still there? Do we continue with this or
Around 50 attendees are still there, sir.
Okay, so that's good. 50
Yes,
means
yes,
they are truly interested.
yes,
That's
yes.
very good. Okay. So let us, so we have, if anybody has got any question or if anybody wants that it should be elaborated, you should tell me immediately. And now that this is very important because again the machine intelligence will be a major area of our studies in data science. So we have talked about the big data, we have talked about big data analytics, we have talked about the descriptive and predictive and prescriptive statistics. For that you will be taught statistics. Probability and statistics will be a very important paper in data science. It's very easy, it's not at all difficult. That means statistically you have to say that how much amount of, what is the probability that this is going to happen. So earlier we used to have descriptive statistics, then it becomes, the predictive, it can predict that this is what is going to happen. Now it is prescriptive, that is from the huge amount of data, you have to give the prescription. You have to tell the user that you have to do it. Okay. So for that optimization is very important. That also will be taught in that subject. So this is about the statistical analysis and optimization. So this will be taught in our area. Then the big data analytics will be taught. Then how the data security can be ensured, that will be taught. That will be a very important area. IoT, that I said, that sensor, large number of sensors connected with the cloud. So IoT and cloud computing and sensor technology, these will be taught. And most importantly, the machine learning, which is, that means at the end of the day, you have to give some, decision, because big data means data is there. Now the data analytics should tell you that, okay, this is what you have to do. You have to make use of the data. For that, the machine intelligence, AI and machine intelligence will be a big thing. It started in the year 1942. And then it continued, and today we call it that this is an era of, the convolution neural network. I'll just only show you some of them because neural networks are very easy. Those who are in computer science, you might have studied it in your BTech program. I do not know, maybe in final year. It's very easy, I mean, because in human biological neural system, there are a large number of neurons which are interconnected with each other. So every set of neurons are again mapped to another set of neurons. They are again mapped to another set of neurons. And as you can see that there are, after mapping from 128 to 128, whatever was the information, that is now mapped to 64 by 64. That is now mapped to 32 by 32. So as you can see that the mapping in each layer, it is going on. So since there are a large number of such layers, it is known as deep layers, so deep learning. So this is a convolution network. I do not know if all the 50, if they are interested, I can go more in detail. But then let me just only talk about the examples. For example, this is a simple thing, that is our handwriting, handwriting analyzer. You have written, thousands of people can write 1, 2, 3 or A to Z in different ways. But then you can train the machine using different handwritings which are known. And then once the network is trained, that means after the deep learning means there are large number of neural network, layers. And finally it is classified. Suppose this is one image. And you will have to find out that what this image is. It has to be recognized. Again here, using a convolution neural network, you have done it. Suppose this is interesting. This is a car. There are different types of cars. And in each layer, after you have convolved it, you can see that how little bit of features you are extracting from the car. So low level feature, mid level feature, and then high level feature. Then finally in a card, there are some features outside you can see. And then it will be trained, and finally you can say that, okay, this is a card or this is this type of card, etc. So face recognition in deep learning. So this is a face. As you can see that we have got several layers of neurons which are interconnected with each other. And then the images are initially given. Then in the first layer, as you can see that you can find out only Sarah, this girl. That means you can only find out the important, line features of her, I mean face. That means the eyes, eyebrows, the hair, etc., ears. Then comes the middle level features. And then at the last, finally, you can see that if there are a large number of such, images, all have been mapped there. And now if you give this girl's feature, then finally the machine should say that this is Sarah, this is girl. So this is a typical, machine learning using for face recognition. So there is n number of such applications, n number of such applications. There is no area which is not touched by, whether it is machine learning or IoT or big data analytics, and for everything you need the data security. So an ensemble of all these together gives you the data science, the whole. As you can see that here, the deep learning at the output layer, you have got all the different phases which are given. So I very quickly, I just went through the slides, and now you can, I think that we can interact. Am I in time or I did a little bit fast?
No, sir, it's absolutely within the time limit. Because
Okay.
we started little late, so it is
okay. So
okay.
it's okay. Now the question is, if anybody has got any query, then you can ask me. This is number one. Although in each one of them there will be detailed, classes which our teachers will take in the next few years. There will be total 42 webinars, 44, I suppose. Some are in data science, some in health science, some will be in interdisciplinary sciences, etc. So you can, the whole idea is that we wanted that it should be our students, they should be, given the opportunity to have a rudimentary knowledge on each one of them so that they know they can decide that what they are going to do. Next. So if there is any question, then you can ask me.
Yes, sir. There are some questions.
Yeah, you can tell me the question so that others also can.
Gaurav Chakraborty, he has asked that is fuzzy logic used in deep learning?
Oh, that's yeah. The answer is yes. But then the major thing is that not much of work has been, in fact, that is one of my own, in areas of interest. So one of the research scholars here will be working on that, because in deep learning, we need, the data that you are getting, they are all very imprecise data. In most of the databases, the data is uncertain, data is, not only uncertain, they are very, very imprecise data. So it needs the fuzzy logic to handle such data. So, the soft computing, which I forgot to mention, and that will be one of the major areas in which the data science will move now. Because in uncertain areas, the imprecise data, you do not really know that how to tackle that imprecise data. You need to learn or train the neural network using this kind of, imprecise data set. For that, fuzzy logic will be a wonderful thing. Yes, in deep learning also fuzzy logic can be employed in a big way. Yeah, very good. Next. Prosenjit,
Yes, sir, I am here. So the next question is, uh, what is the use of a perceptron? The same person is asking, Gaurav Chakraborty.
perceptron, in fact, in 1957, it was one gentleman, his name was Rosenblatt. He had for the first time talked about a pattern recognizer which was known as perceptron. He gave the name as perceptron to a sort of rudimentary neural network. Neural network started in 1942 by McCulloch and Pitts. But this perceptron had kept a huge wave. A lot of industries went to Rosenblatt and they said that we would like to give you projects for doing this. So what is that? Perceptron was used for pattern classification. Suppose there are two classes of patterns. One class of pattern is, say, for example, the cow. The other classes of patterns is, say, goat. So you train the machine with the pictures of cows, you train the machine then again with the pictures of goats. Now once the machine has learned, this is known as machine learning. Then you feed the machine with a picture of cow, the machine should be able to say that this is cow. Like that, so there are two phases. One is training, just as in the same way as the human beings learn. So in human beings, we have got a biological neural network. So computer scientists or mathematicians, they try to model that human neurons to an artificial neuron, and that is known as artificial neural network. The kind of things that we are talking about, they are all artificial neural network. And there we have to have such kinds of, the perceptron. Then it became multi-layered perceptron in 1983. Rumelhart and group, they talked about a 3-layered architecture for perceptron. Original perceptron, it could not classify the patterns which were linearly separable, but the MLP, that is the multi-layered perceptron, could, do it, could recognize the patterns which were non-linearly separable. That means two classes of patterns, if you just draw it on a two-dimensional graph, x-axis, y-axis, have one class of patterns clustered somewhere, have another kind of patterns clustered somewhere. And then if you can have one line, straight line between them, then we say that these are linearly classified. So anyway, so that was again refined by Rumelhart in 1983. So neural network, it had again, that's an evolution. It evolved a lot. And this convolution neural network, it started in 90s only, but then we were unable to process them because the computing resources were not there. We didn't have any GPU kind of thing, that one that you have today. We did not have any concept of, big data, because these are all new things which are coming up. So, so the whole thing is that now in this new environment, we have to think about the new kind of technologies which have already come. And this is possibly the data science with all its, different angles, with lots of applications in almost all the areas. This is the technology of today and tomorrow. So as the job prospects are concerned, almost majority of the jobs now in computer science, IT and these areas will go to them who are known to the areas of data science, who know about, say Python, who know about how to write codes for, machine learning, how to write, the big data, how to handle them, data security, how to handle them. So those who will learn these things, so naturally the industries and the companies, they will require this kind of data, and in many, many different application areas, whether it's healthcare, hospitals will need it, doctors will need it, the drug manufacturers will need it, the agricultural people will need it, and who will do it? The same IBM will do it. They will take the, suppose the electricity, utility area, they will, because today's, world, they take these big houses, they take the projects from all these, other big houses. That is whether it is, say, Fertilizer Corporation of India, they will give the project to, say, IBM or say to PwC. Large number of such projects. So these are all big corporate houses. They take the projects and they take our students who are doing these projects. And a large number of them, they are doing it. But then ultimately at the end of the day, they will see that how much in these areas. And so as I said that these three areas, that is our health science, our data science, and also the interdisciplinary sciences, these three are the three areas where I can tell you the whole world is moving in these three areas, and there is nothing more. Everything comes under the purview of this, whether it is environment, healthcare, everything, or even in business. Because from tomorrow onwards, a lot of business case studies will be shown. That means the businessmen, they need their profits. The financial, people, banking, the LICs kind of things, insurance companies. So there are a large number of such projects. Majority of the IT projects in India are in finance. So there also you need the same kind of things. Same big data, same AI and machine intelligence, same data security. Everything is the same. And in the applications, you need the same IoTs. So, my dear friends, you will need to require, wherever you study, that is your own decision. But then in this institute, we have started these three new centers. We are working together and we are working in a consolidated way so that the teachers of each of these three centers, they are doing it together. And in future, we'll be taking more number of faculty members and we are going to grow because after all, these three are the major three areas where the whole world will move tomorrow. And any other question?
No, sir, there is no question. So in that case, I think, yeah, the Dr. Kaushik Bosat from Data Science is here. If he wants to comment anything.
Okay.
Dr. Bosat, are you there? Because he is from Data Science.
Mm-hmm.
Yeah. Dr. Bosat, if you want to comment anything.
Kaushik, you can.
Yes, Chief. Yeah, no, as per the lecture was pretty much splendid and I listened to all the things. And like, just to say sure, like whether the slides that you were presenting, that would be shareable to the students or?
Kaushik, a little bit louder.
Yeah, slides shall be shared. If our speaker permits, I think I will speak to Professor Ray. I think recording is already there. If slides anybody needs,
slides can be shared, no problem.
Yeah. Okay.
Yeah. So, my dear students, so if you have got any queries which you cannot do now, then you can send us mails. Prashanjit, my address is, how can I write? Prashanjit, can you?
Yeah, I can write it on the chat box. Yeah, your email ID, both of.
Okay,
emails.
so Dr. Shaha will write it. You can ask any question that comes to your mind. Any question.
In future, they can in touch with you. Sir.
Right. Yeah. So, no, but then, yeah, this is director at JISIASR.org.
Right. Another one I am writing.
IASR is JIS Institute of Advanced Studies and Research and .org. And let me tell you that currently we have got some MTech and many PhD students and many, they are now very much interested to join us. Yeah. So another one is ray.ajoy, ray.ajoy. 2018
I have written down.
@gmail.com. Okay, all the best to all the participants.
Okay, sir. Thank you, sir. Thank you for such a nice presentation and for your time. We will be in touch with all the participants. If anything they require, they have query. So
Anything, any query you have got, you can once again send them that to all those who have joined.
yes, sir. Yes.
All the best to all of you, and my real best wishes. Please have that confidence in mind that tomorrow it will be your day and everything will be fine tomorrow. Not get absolutely, frustrated in this pandemic situation. I'm sure that brighter days are coming, and only thing is the self-confidence, and the more you learn it properly, the more you learn, the more confident you become. And one of the things is you should always keep on asking questions, and because this is the thing which is required. Asking question is very important in my opinion. Any question, remember that no question is a bad question. Any question that comes to your mind. So it's always better to ask as many questions as possible. So
So right now we are having one question, sir. In the last moment, I think Sangeeta Roy, she is asking how can reduce computer configuration requirement, that is high-end to low-end computer.
Yeah, that's again an interesting question. You know, as I said, that from high-end those servers, now we are going to commodity servers. Commodity means they are much more cheaper. So the whole idea of today's analytics of big data is that you do not, stack it up, do not make it more complex, but then you distribute it. Distribute the job, whether it's storage or processing, everything horizontally, not vertically. You know, horizontally you keep on distributing. You need, say, 2 more blocks. You purchase 2 more blocks from the market. So like that. Okay. So that will take care of the data analysis. A huge volume of data, you will find that that can be analyzed in a very short time. But then if you make everything centralized, in my opinion, centralized systems do not work. In our country also, politically, you will find that any system that is completely centralized, where every power is in only few persons' hands, that system never works. Democracy means it is completely, decentralized. Of course, in our country, it is only by name. But then, decentralization always is a big model, and it's a much better model than centralized kind of. So we had the distributed processing, distributed computing for last 30 years. Lots of research have been done. But today, the requirements are such that we have to go for this kind of Apache Hadoop, Spark, or even NoSQL, that kind of a situation where we will be using things. And remember that these are not difficult. When we were students, we have not even heard of all these things, technologies. And then we have to start, everything. Even at this age, you have to learn new things every day. So you are all young people and you will learn very easily. So in this series, we'll be having slightly better again. Anaconda, please try to, those who will be attending tomorrow, you can download it today so that it will be easier for you to understand the things for tomorrow. In fact, I do not know. I had to move a bit faster today because I really didn't know about the timings and all. And you can give your feedback and anything that you need. Thank you very much.
Thank you, sir. Thank you. We should log off right now.
Okay.
So thank you. Stay safe and stay healthy. Tomorrow we will meet again at 3 o'clock.
Tomorrow at same time, 3 o'clock.
Thank you. Thank you, sir. Thank you all the attendees. Okay. Goodbye.
Bye.